All right, class, today we're going to be solving absolute value we're going to be solving inequalities. We're going to be able to solve any equality that we are approached with. Whenever we're solving inequalities, you want to think about intervals. You always want to consider what interval is going to make the solution true. So we're going to start out by solving this as if this were a normal equation. So I have 2x squared plus 5x minus 12 equals 0. We'll consider the inequality later. So I want to think about factors of 2 times 12, which would be negative 24, that when I add them up, I get 5. And those two numbers would be 8 and 3, where it appears that 3 is going to have to be the negative. So now I'll split the middle term up and factor. Group. So I'll pull out a 2x from the first group and be left with x plus 4. And I will pull out a 3, negative 3 from the second group, and be left with x plus 4. So my two factors are 2x minus 3 and x plus 4. So my two solutions will come from 2x minus 3 equals 0 and x plus 4 equals 0. So here x equals 3 halves, and here x equals negative 4. If this was a normal equation, I would be done solving. But this is an inequality. I want to think about where this graph is greater than, or this equation is greater than 0. So what I'm going to do is create some test intervals, and it helps to view this on a number line. So negative 4 is here on the number line, and 3 halves is here. So I have created 3 intervals that I'm going to have to test to see if they work. And I can pick any number. Often I pick the number that I feel like is going to be easiest to solve. And you don't necessarily have to show all this work when you do it, but I will for example's sake. So I'll start with the middle interval, because that's often the easiest because I can plug in 0. And I want to see if this makes the statement true. So this and this both cancel out, and I'm left with negative 12 is greater than 0, which is not true. So this section from negative 4 to 3 halves is going to be false, or will not be part of my solution. So now I need to test the outer parts. I need to think of a number that is less than negative 4. And so what better number than negative 5? Again, you could pick any negative number you want, just as long as it is less than negative 4. And a lot of times you can do this math in your head. 2 times negative 5 squared, that's 50. And then minus 25 minus 12 gives me 13. And 13 is in fact greater than 0, so this is true. So this section, or this interval, will be part of my solution. And then the final part, I need to test a number that is bigger than 1, or 3.5, or 3 over 2, which I could just pick 2, because 3 over 2 is just 1.5. So 2 times 2 squared plus 5 times 2 minus 12. And again, I can do this in my head most of the time. And is it greater than 0? So I know that 2 times 2 squared, that's 8. And then 5 times 2 is 10. And subtract 12, so I have 6 is greater than 0. So since that's true, I can assume that everything within this interval is true. So my two intervals that are the solution to this inequality are the intervals from negative infinity to 4 and from 3/2 to infinity. I know I have round brackets around the infinities. Since I have a greater than and not a greater than or equal to, I have round brackets. This would be my solution. Let's go ahead and solve this one. It's a cubic graph. I notice that I have an x in both terms, so I can factor out an x. And have x squared minus 4. And this factored portion can even factor further, since it's the difference of squares. And so my three solutions to this equation would be x equals 0, x equals 2, and x equals -2. But since this is an inequality and not an equation, I'm not done. I know I have closed dots. I'll keep that in mind for the future. And I'm going to create my little number line and think about my test intervals. So I have 1, 2, 3, 4 possible intervals for my solution here. And again, I need to pick in numbers. This time I can't plug in 0 because 0 won't tell me if an interval will work. But I can plug in 1 and -1. So 1 to the third minus 4 times 1, is that greater than or equal to 0? 1 minus 4 is -3, which is not greater than or equal to 0. So the interval that includes 1 is not a solution. Or that part creates a false statement. Let's do another test. Let's test -1. So -1 to the third minus 4 times -1 is greater than or equal to 0. Is that true? -1 to the third is -1 plus 4. So that's 3, and 3 is greater than 0. So this interval here would be a true interval, or part of my solution set. Now I just need to test the outer intervals, and I just have to pick a number that's bigger than 2. How about 3? So 3 cubed minus 4 times 3 is greater than or equal to 0. So 3 cubed is 27 minus 12. I know that that's greater than 0. So this is also going to be a true interval, or a solution to my answer, or to my equation. Now, I need to pick a number less than -2 to test the final interval. How about I test -3? So -3 to the third minus 4 times -3 is greater than or equal to 0. So this is -27 plus 12 is greater than or equal to 0, which is a negative number, which is not greater than or equal to 0. So this portion would be false. So the only two parts of my solution are between -2 and 0, and from 2 to infinity. So I just need to express it. Since it's greater than or equal to, I have square brackets, -2 to 0, and from 2 to infinity. We'll talk about this more in class. Please write down any questions that you have, and we will go over them.